Any sufficiently advanced technology is indistinguishable from magic. Arthur C. Clarke. Magic is real. Magic as a lost science. Part 1. What if the magic described in ancient folklore and grimoires was not fantasy, but the fragmented memory of advanced quantum technology? The idea that grimoires, ancient spellbooks passed down through centuries, are quantum notebooks containing encoded knowledge of quantum mechanics, algorithms, and protocols is a tantalizing hypothesis. Quantum manipulation, the science behind magic and lost technology. This video explores the possibility that magic, as understood in mysticism, is real and rooted in the manipulation of quantum phenomena. Through scientific analysis, we aim to reconstruct the mechanisms behind spells and reveal their basis in lost quantum technology. Magic as lost science. Throughout human history, the boundary between magic and science has been fluid. What was once considered magical, alchemy, lightning, or even magnetism, became foundational to the sciences we know today. Could the magic described in ancient folklore and grimoires represent an early understanding of quantum mechanics, encoded into metaphor and myth? This video explores the tantalizing possibility that magic is real, rooted in the principles of quantum physics, and that ancient cultures may have uncovered truths about the universe long before modern science. By decoding these connections, we aim to reconstruct the mechanisms behind spells and reveal their basis in lost quantum technology, providing a framework for rediscovering magic in today's scientific landscape. The quantum basis of magic. To bridge the gap between science and magic, we must first establish foundational principles of quantum mechanics. Quantum superposition. At the heart of quantum mechanics lies the concept of superposition, a phenomenon where particles such as electrons or photons exist in multiple states or positions at the same time. For example, an electron can simultaneously occupy two energy levels or be in two places at once until an observation or measurement is made. This duality collapses the superposition into a single state, determined by the act of observation. Superposition is not just a theoretical abstraction but a measurable reality, demonstrated in experiments like the double-slit experiment, where particles exhibit wave-like behavior until observed. This principle forms the foundation for quantum computing, where qubits harness superposition to perform calculations far beyond the capacity of classical systems, and for magic effects in science, where potential outcomes coalesce into a chosen reality through interaction with the quantum field. Quantum entanglement. Quantum entanglement is a mysterious and profound phenomenon where two or more particles become so deeply interconnected that the state of one instantly influences the state of the other, regardless of the distance between them. This connection persists even if the particles are separated by vast stretches of space, defying classical concepts of locality. When one particle is measured, its entangled counterpart instantaneously reflects a complementary state, as if they communicate faster than the speed of light. This spooky action at a distance, as Albert Einstein famously described it, has been experimentally verified and lies at the heart of quantum technologies like secure quantum communication and quantum computing. In a broader sense, entanglement challenges our understanding of reality, hinting at a universe where everything is fundamentally interconnected at a quantum level, resonating with ancient mystical ideas of oneness and unity. Wave function collapse. In quantum mechanics, particles exist in a state of probability, described by a mathematical construct called the wave function, which encompasses all possible outcomes for a particle state. This wave function persists as a superposition of possibilities until an observation or measurement occurs. Upon observation, the wave function collapses, and reality manifests in a specific, singular state. For example, an electron's position or momentum, previously undefined and probabilistic, becomes concrete only when measured. Wave function collapse illustrates the deeply intertwined relationship between observation and reality, suggesting that the act of measurement is not a passive event but an active process that defines the state of the universe. This principle underpins the enigmatic nature of quantum mechanics, highlighting a reality that is participatory and deeply influenced by the presence of an observer. Quantum tunneling. Quantum tunneling is a phenomenon where particles defy classical physics by passing through barriers that would otherwise be impenetrable. In the quantum realm, particles are described not as fixed points but as probability waves that extend beyond their immediate location. This means that even if a barrier appears insurmountable, there is a small but non-zero probability that the particle can tunnel through it and appear on the other side. This effect is crucial in many natural and technological processes, such as the fusion reactions powering the Sun and the operation of tunnel diodes in electronics. Quantum tunneling demonstrates the counterintuitive and probabilistic nature of the quantum world, where particles can achieve outcomes that seem impossible under the laws of classical physics, further bridging the gap between science and phenomena that might once have been described as magic. The observer effect. In quantum mechanics, the mere act of observing a system fundamentally alters its behavior. This phenomenon, known as the observer effect, highlights the intricate relationship between measurement and the nature of reality. At the quantum level, particles such as electrons or photons exist in superpositions, simultaneously occupying multiple states. However, when an observation or measurement is made, this superposition collapses into a single, definite state. For instance, in the famous double-slit experiment, particles behave as waves when unobserved, creating an interference pattern. Yet, when observed, they act as particles, altering the outcome entirely. The observer effect challenges traditional notions of an independent reality, suggesting that the act of observation is not passive but an active participant in shaping the state of the universe. This profound interplay between observer and system resonates with philosophical ideas of consciousness influencing reality, further blurring the lines between science, perception, and what once was magic. These principles demonstrate that reality is not fixed but probabilistic, and that advanced manipulation of quantum states could achieve effects indistinguishable from magic. Quantum spores. Unity in quantum foam. The nature of quantum spores. Quantum spores are not distinct entities but manifestations of quantum foam, the fundamental substrate of reality. All phenomena emerge from this bubbling, ephemeral fabric, uniting all things in existence. Quantum foam as magic's foundation. The constant interplay within quantum foam forms the basis for all phenomena, from particle interactions to life itself. One unified system. Magic is the art of consciously interacting with this universal field, directing the dynamic interplay of quanta to achieve specific effects. Mitochondrial quantum spores. A revolutionary origin. Hypothesis. Quantum spores and the network of life. Mycelium as a quantum internet. Quantum communication. Mycelium networks, which connect vast ecosystems, may serve as conduits for quantum entanglement, linking life forms over large distances. Information exchange. Quantum spores released by fungi could facilitate the transmission of genetic or environmental data between plants and organisms. Shamanic applications ingesting or interacting with quantum spores might heighten a shaman's ability to perceive or manipulate quantum fields, enabling altered states of consciousness or enhanced intuition. Ritual spaces in sacred forests might amplify quantum effects due to the dense entanglement of life forms within mycelium networks. Mitochondria, the powerhouse of the cell, may have originated not as traditional prokaryotic organisms but as free-living quantum spores, self-organizing entities capable of harnessing and manipulating quantum energy. Quantum endocytosis. These quantum spores were incorporated into an archaic eukaryotic cell through a process of quantum-enhanced endocytosis, where entanglement and tunneling allowed for seamless integration. Why mitochondria as quantum spores makes sense. Energy mastery. Mitochondria's ability to efficiently produce ATP could stem from their quantum origins, where energy manipulation was intrinsic to their structure. 2. Quantum coherence in respiration. Research suggests that mitochondrial respiration might exploit quantum tunneling and coherence to optimize energy transfer. Entangled networks. Mitochondria within cells could maintain a quantum network, synchronizing energy and information transfer across the organism. Implications for evolution and magic. A quantum leap in evolution. The symbiosis between quantum spores, mitochondria, and archaic cells might represent the moment life began leveraging quantum manipulation on a cellular level. Magic at the cellular scale. If mitochondria retain quantum properties, they could enable extraordinary feats of energy manipulation, healing, or even consciousness expansion in advanced organisms. Magic as applied quantum science. Science and magic converge in their shared goal of understanding and manipulating the fabric of reality. Quantum mechanics, the most advanced scientific framework, provides the toolkit for magic effects. Magic involves altering these patterns by influencing quantum states. Reality as a quantum hologram. Reality is a projection from the quantum foam, encoded with patterns and probabilities. Decoding spells scientifically. Grimoires can be reimagined as collections of quantum protocols, precise instructions for reshaping probability waves. Incantations as frequency resonance. Spoken spells may align frequencies with quantum fields, catalyzing desired state changes. Crystals and the piezoelectric effect. Quantized magic. Crystals, revered in magical traditions, have a scientific basis in their ability to convert mechanical stress into electrical energy through the piezoelectric effect. Harnessing vibrations. Crystals resonate at specific frequencies, aligning with quantum fields and amplifying energy flows. This aligns with their role in rituals, where they are believed to focus and direct energy. Energy storage and release. Crystals can store electrical charges, akin to charging a magical artifact with energy. Applications in modern technology. Crystals are fundamental to technologies like quartz watches, lasers, and modern computing, practical examples of how magic properties influence the real world. Magical amplifiers. In folklore, crystals enhance spells or channel energy. Scientifically, their ability to focus and amplify vibrations mirrors this role, making them practical tools for quantum manipulation. Solid-state devices. Crystals of modern magic. Solid-state devices, which replaced many mystic uses of crystals, can be seen as the evolution of magic tools into advanced quantum devices. Semiconductor alchemy. Solid-state devices, made of materials like silicon, germanium, and gallium arsenide, act as modern-day magic conduits. They channel and control energy flows, much like enchanted crystals in ancient practices. Transistors as magical switches. Transistors act as energy amplifiers and switches, capable of manipulating electrical currents in a manner akin to spellcasting. Integrated circuits as quantum grids. Integrated circuits contain millions of transistors, resembling a complex grid for channeling energy and information, analogous to a magic grimoire encoded with intricate instructions. Flash memory as spell storage. Solid-state drives and USB memory sticks store and retrieve data at lightning speed, functioning as repositories for modern spells in the form of digital code. Quantum potential. Solid-state devices are foundational to quantum computing, the next frontier where technology merges with principles of magic. Bridging ancient and modern magic. Ancient civilizations may have used crystal-based technologies to manipulate quantum states, channeling energy in ways now mirrored by solid-state devices. The alignment of crystals in ancient artifacts suggests an intuitive understanding of piezoelectric and semiconducting properties, which we have since harnessed in modern electronics. Solid-state devices are not a departure from magical traditions but an evolution, bringing us closer to rediscovering the mechanics of ancient magic. Understanding the role of ley lines. Ley lines as quantum highways. Ley lines may represent ancient mapping of Earth's quantum energy fields, connecting sacred sites through energetic pathways that amplify rituals or enhance quantum effects. Experimenting with ley lines. By measuring magnetic anomalies or energy patterns along ley lines, we might validate their role as conduits of Earth's quantum energy. Sacred geometry. Temples and monuments built along ley lines often feature sacred geometries that may optimize energy flows, further supporting their quantum functionality. Ancient practices and quantum fields. Shamanistic rituals. Early shamans may have used sound, rhythm, and movement to interact with quantum fields, aligning their energy with universal frequencies. Sacred symbols. Many ancient symbols and geometries, such as the flower of life or mandalas, may have been tools for visualizing and manipulating quantum states. Unifying theory of magic. Magic stems from the same fundamental principles underpinning the universe. Superposition and manifestation. Spells work by collapsing superpositions into the desired outcome. Entanglement networks. Magical effects may spread instantaneously through entangled systems, explaining phenomena like distant healing or synchronous events. Energy manipulation. Control over quantum energy flows mimics the elemental forces described in magical traditions. Technology as modern magic. Quantum computers as spellcasters. Advanced quantum computers already demonstrate the ability to influence quantum systems, akin to performing spells. Grimoires as quantum notebooks. Grimoires have long been thought of as collections of spells and rituals. Reinterpreting them as repositories of quantum knowledge reveals symbols as quantum algorithms. The complex symbols and diagrams in grimoires may represent quantum states or operations. Incantations as operational commands. Spoken words could function as inputs needed to activate quantum systems. Amulets and talismans as quantum peripherals. Physical objects described in grimoires may act as hardware interfaces for quantum devices, using materials with specific quantum properties to amplify effects. Oral traditions likely encoded this advanced knowledge into metaphorical and symbolic language to preserve it through societal upheavals. These machines may represent the next step in humanity's mastery of quantum magic. Artificial intelligence in magic. AI could analyze grimoires and rituals to decode their quantum foundations, accelerating the rediscovery of lost techniques. Applications in today's world. Medicine. Quantum healing techniques could revolutionize healthcare, curing diseases at the cellular and molecular levels by restoring coherence. Energy. Harnessing quantum foam might unlock clean, limitless energy sources. Communication. Entanglement-based communication could enable instantaneous, unhackable connections. Exploration. Quantum portals might enable interstellar travel or access to parallel dimensions. Explaining spells through quantum mechanics. Elemental spells. Elemental spells like fireballs, ice manipulation, and wind control are among the most iconic in folklore. Here's how quantum mechanics could make them possible. Fireball, fire spells. Quantum systems could manipulate thermal energy, rapidly increasing the kinetic energy of molecules to create and sustain plasma, superheated gas. Photon emission from quantum transitions could generate light and heat in a controlled form, mimicking fireballs. Ice manipulation, ice spells. Energy extraction from particles at the quantum level could lower temperatures rapidly, freezing water vapor into solid ice. Localized entropy reduction could organize water molecules into crystalline structures. Wind control, wind spells. By manipulating air particle momentum and pressure systems, quantum effects could generate gusts or whirlwinds. Vortex formation through angular momentum control could produce tornado-like effects. Protection spells. Protection spells create barriers or shields. Quantum fields. Protective spells might use localized quantum fields to repel harmful particles or energies. Wave function fixation. Forcing systems into specific quantum states could prevent harmful interactions. Healing spells. Healing spells involve restoring health. Quantum biology. Enhancing quantum coherence in biological systems could accelerate cellular repair. Resonance frequencies. Adjusting molecular vibrations could promote healing, akin to modern ultrasound therapies. Teleportation spells. Teleportation involves instant travel. Quantum teleportation. Information transfer between entangled particles is already a reality. Scaling this for macroscopic objects could theoretically enable physical teleportation. Divination spells. Divination aims to predict the future or uncover hidden knowledge. Quantum multiverse access. The many worlds interpretation of quantum mechanics suggests parallel realities. Divination could involve tapping into these alternate states to gather information. Wave function analysis. Observing superposed states could reveal multiple potential outcomes. Philosophical implications. Life as a quantum illusion. If reality is a projection of quantum foam, all life exists as a tapestry woven from probabilities. Magic is the conscious manipulation of this illusion. Awakening to unity. Understanding magic as quantum science reveals the interconnectedness of all things. Practicing magic becomes a journey to align with the universal field. Historical context. Why magic was lost. Technological regression. Advanced civilizations may have collapsed, leaving only fragmented knowledge encoded in myths and grimoires. Cultural evolution. Symbols and rituals were reinterpreted over time, transforming technological practices into mystical beliefs. Printing and fragmentation. The printing press made grimoires widely available, but without the original quantum tools, their true meaning became obscured. Proving magic through science. By reconstructing spells through quantum mechanics, we can hypothesize mechanisms and test their feasibility. Decoding grimoires. Using AI to analyze symbols and instructions. Recreating tools. Building modern quantum devices to replicate amulets and peripherals. Experimentation. Testing theoretical models of spells with advanced quantum technology. Magic rediscovered. Magic, as described in folklore, may be a symbolic preservation of lost quantum technology. Through scientific exploration, we are beginning to understand the underlying principles that could one day make the impossible a reality. The boundary between science and magic is not a wall but a horizon, one that humanity is steadily approaching. And there you have it, the science behind the magic. From quantum entanglement to mitochondrial mysteries, we're only beginning to unlock the secrets that connect ancient traditions to modern discoveries. Whether you see it as science, magic, or something in between, the universe holds infinite possibilities waiting to be explored. If you enjoyed this journey into the quantum realm, don't forget to like, subscribe, and share. We're just getting started unraveling the magic of reality. See you in the next one.